Hello and welcome to this tutorial on how to solve circuit diagrams. I think it will be helpful. We're going to go through three different types. One is a series circuit, one is a parallel circuit, and the last one is a mixture, a combination of the two, it's a little bit more confusing, but I think we will get through it just fine. Okay, and so we've done these in class, but we're going to do them like this as well, and hopefully this will help make it a little bit more clear. So here's our first circuit. What kind of circuit is this? It has one pathway, so this is a series circuit. And in class, you got a set of notes that looks like this, and we filled in rules for how series and parallel circuits work. So a series circuit has one path like that, and we had rules for that. Same with parallel circuits. And these four boxes here, you need to know them. Okay, they will be very important for the test. Okay, so let's just think about a series circuit right now, because that's what we're dealing with here. So the rules say that the voltage drops, or the voltage lost across resistors, adds up to the total voltage. So we have three drops here, 1, 2, 3, through resistors. And the voltage across number 1, number 2, and number 3 should add up to the total voltage. And the total voltage in this case is 20 volts. Okay, so V1, V2, and V3 should add up to 20 volts. For current in a series circuit, you have to think of it like a train. You've got all these electrons and they're in a row like train cars, and so the current is the same through the whole circuit, right? If the back part of the train is going 20 kilometers per hour, the front part of the train would also be going 20 kilometers per hour. And so it is with electrons, okay? In a series circuit, because there's only one path, they're all going to be going at the same velocity, and so we have current being the same throughout there. Okay. Knowing that, we can start solving things in our circuit. Okay, and so here's our circuit. We've got some information. The voltage of the battery is 20 volts. It looks like that's cut off a little bit there, but that's 20 volts. And I've also given you this. The strength of resistor 1, the strength of this resistor is 5 ohms. The current, remember I is current, through resistor 2, the current through there is 2 amps. And the voltage drop across resistor 3 is 6 volts. And what we want to do is we want to fill in the rest of the boxes. So where should we start? That's often a tricky question, especially on a test, right? Where do I start? And I would suggest just try it anywhere, right? You could try here or here, and if they don't work, move on, try another one. In this case, this is a series circuit, and we know that the current is the same everywhere. So if this is 2 amps, then these ones are going to be 2 amps as well. There's going to be 2 amps running through here and through there. Okay? So we've made progress. I also told you in class I would suggest leaving resistance for last. Because for resistance, the only way to find it is through Ohm's law. Okay, what is Ohm's law? Well, it's a mathematical relationship between voltage, current, and resistance. Voltage, current, resistance. And so we use this handy triangle to represent that formula. Okay, anytime we have two values in a column going up and down, like here, we can figure out the third one using Ohm's law. So voltage, if I want to solve for that, I can use the formula. And so voltage, if I cover that, is equal to I times R. If they're beside each other in the formula here in the triangle, this means times. Okay, so voltage equals I times R. So the voltage across resistor 1 is equal to the current through resistor 1 times the resistance of resistor 1. Okay, so there's our formula, which you're expected to write And now we can put in the values because we know I1, it's 2 amps, and we know R1, it's 5 ohms. Like that. Okay, and you're allowed to use a calculator. So 2 amps times 5 ohms, that is 10, and voltage is measured in volts. Okay, so we've just solved another box there. Okay. For this one, it would be nice if we had the resistance, but we don't have the resistance, so we can't use Ohm's law to solve for V2. But we do know the rule for voltage. So voltage, remember, in a series circuit like these voltages have to add up to the total voltage of 20 volts. Okay, so that means V1 plus V2 plus V3 should add up to 20 volts. Now you might look at that and think, oh, 10 and 6, that's 16, so this has to be 4. That's great. You do need to write a formula, and so the formula we use for this is simply just take the total voltage and then subtract the other two. Okay, so V total minus V1 and minus V3. Okay, and we have all those values, right? V total is 20 volts, V1 is 10 volts, and V3 is 6 volts. And again, you can use a calculator if you want. 20 volts minus 10 volts is 10 minus another 6, that is 4 volts. Okay, so the voltage lost across resistor 2 is 4 volts. Okay, and now we only have R2 and R3 to solve for. Okay, how can we do that? Well, R2 is equal to, so R is equal to V over I. The only way to find resistance is V divided by I. Okay, so R is equal to V divided by I. And we have those values, right? We have V2 and we have I2. So resistance, you're always going to have to do that, right? This will be V3 over I3. Okay. If we didn't know R1, we'd have to do V1 divided by I1. So V2 over I2, that's 4 volts over 2 amps. 4 divided by 2 is 2, and resistance is measured in ohms. So the strength of this resistor is 2 ohms. Okay? And so the last one, R3 is equal to V3 over I3. We've got that third voltage, we've got the current through resistor 3. 6 volts over 2 amps, and that is 3 ohms. Okay? So that is how you solve a series circuit. Try to do the examples that are in the handout, and then move on to the next video on solving parallel circuits.